Hey there, viewers. Going to briefly talk about space weather. You know what space weather is, right? Space weather is induced by the sun. It's the way the solar wind and Earth's magnetosphere interact with each other. You know, what's occurring at about 100 kilometers and higher? Something like that. The weather in space, where we have mostly charged particles, unlike Earth weather, where we have mostly neutral particles. Space weather. It'll be only increasingly important in the coming years, especially with the emphasis on private space flight. So, yeah, the channel's ahead of the curve, so far ahead of the curve that many of you may have never even heard of space weather. In any case, there's always weather going on in space. The sun's always up to something. And today, we're going to talk about how many sunspots and so forth. It's going to be a brief stream because I'm feeling badly. I might sound great, but I'm not. So, yeah, I'm a trained vocalist. So, getting over the flu, or trying to, and it hasn't been going well. It's been going badly, very badly. And it's extremely frustrating. So, of course, as an athlete, we always like to downplay and minimize injuries and illnesses. And because we downplay and minimize injuries and illnesses, sometimes we inadvertently prolong injuries and illnesses. Yeah, that's a thing. So don't do that, folks. That's not a good thing. Don't have a relapse if you're like recovered. Like, don't overdo it too fast. That's a terrible idea. Not that I've overdone it too fast. I've been very responsible. But, typically what happens with me when I get the flu is that I get brain fog, low-grade fever, a little bit of fatigue, and that's usually it. No respiratory symptoms typically will occur with me. I don't know if that's because I have the cardiovascular system of champions or what, but for whatever reason, I don't get a respiratory symptom from a thing like the flu, ever. It's little more than an annoyance, typically. But it does break down my energy, and, basically I look at it as a firmware update. My immune system's firmware gets updated, and I end up better off as a result. So let's talk space weather here. I'm bringing up my consoles. So give me a minute, I'll show you the screen, and we'll get this space weather broadcast underway. Thanks for tuning in, everybody who has. Don't forget to press the like button. If you're new to the channel, don't forget to press subscribe. What can I say? You'll miss the content if you don't. Or I guess you could just manually go to the channel all the time. That seems like it would be labor intensive, unnecessarily labor intensive. So anyway, let's see what's going on as far as the closest star. Now, if you're a stargazer, hopefully you're gazing at the closest star, as it is by far the most interesting and the most integral to your existence. Current sunspot number, according to the Royal Observatory of Belgium, is 99 sunspots. So we just dropped under 100 sunspots. On the Earth-facing portion of the solar disk, that's the only place we count sunspots. The 10.7 centimeter radial flux is down to 130 solar flux units. There is the graph from solon.info. 130 is the radial flux number. So there's where we are in the cycles. And as far as a space weather enthusiast dashboard, is NOAA forecasting any space weather? We'll find out, but first, the Huxt forecast from University Reading. So there's the Huxt forecast. You see this major CME off in the opposite direction of Earth. So there's that. Not earthly directed. If that were earthly directed, that would be the kind of thing that could shut down some power grids. As you can see, that is very dense and very fast-moving plasma. Wow, that was a CME to remember. Anyway, as far as incoming space weather, here's the situation from NOAA. We ain't got none on the horizon. So it's calm out there. Solar wind conditions are as follows. We do see a weak coronal hole high-speed stream here. So we did see a little spike in the density there, and then a decrease in intensity as the velocity came up. That is the core signature of a coronal hole high-speed stream. Current conditions are about 2 protons per cubic centimeter for the density measured at Lagrangian point 1. 536 kilometers per second is how fast those solar protons are moving. As far as really fast-moving protons, there's only a minor spike here in the proton flux. We did see a little proton event as the channel forecasted because, hey, there was an active sunspot on the western limb, and that's when SEPs, solar energetic particle events, occur. So yeah, we forecasted that one. No big deal. Everybody knows that that's when those things happen. Next, or anybody who knows what we're talking about knows when those things happen. So here's our 3-day GOES X-ray flux. As I didn't do any weekend videos, I've been slacking. So there's our X-ray flux, and you can see the sun is back down to a B-class background flux. So activity's been dropping. As far as the current conditions, let's shrink it down one size. Here you go. That's what's going on in the past couple of hours on the closest star. The GOES 19 SUVI depicting ionized helium. And we do see a bunch of activity here on that eastern limb. So massive filaments here south of the equator, massive filaments up here in the northeast. New active region, lots of filaments here, so there is definitely potential for major space weather. Which is what we like to see, the potential for major space weather. That's good times, good times. And now I've got a thing on the screen that I didn't want on the screen, because reasons. Come on, Chrome. Chrome. That Google software is adorable. It almost even functions. All right, so yeah, that's what's going on. We've got some activity here. Let's take a closer look at the activity, not through stereo A. So not a lot going on here. This coronal hole high-speed stream has caused some perturbations in the Boulder magnetometers. So that's something. Let's take a look at these new active regions. So it's not looking super great. Oh, there's some magnetic shear there. All right, that's not too bad. Let's see. El Teide is the latest. We'll look at El Teide once again. Here is our Gong 2 magnetogram from the National Sunspot Observatory. Yeah, this is a flare producer. That is a significant flare producer right there. So this sunspot right here, I can see right there, there is an area of high magnetic shear. This area is okay. This is my favorite spot for a large solar flare. So that's where a large solar flare is most likely at the moment. Keep in mind, it is also in proximity to the limb. It is really on the limb. And that's a good thing if you like solar flares. If not, then you should be very spooked, very spooked. Let's take a closer look at the evolution of that sunspot. Not a lot to see there, but you can see there is definitely a lot of magnetic shear. You see the way there's stark black and stark white right next to each other? That's what you want to see if you like solar flares. And it's got it. So let's look at filaments next. If you want to name filaments after your friends, foes, or even yourself, then do it over on Twitter. Just use the hashtag name that filament so that we see the tweet. Yeah, the tweet. It's still called Twitter. I don't care what the branding's done. It's still called Twitter. Deal with it. There's no brand called X. That's not a thing. Twitter is a brand. X is a nothing. A letter is not a brand. Next! Look at these filaments. Damn. And this one's getting unstable right now. Look at that. It looks like it's blasting off at the moment. So let's go back to the GOES. I goes back to the GOES. Oh, look at that. That filament's right in the Earth-facing zone. So that filament right there is currently mobilizing, folks. This could become a geomagnetic storm. So fingers crossed for that. It looks like it's even flaring. Yeah. So this is a good spot right here. This spot right here. Expect a CME anytime, really. All right, continuing on here, we're going to show some more data. Let's look at our intensity grant, or our coronal hole line of sight plot. Let's make sure we've got the newest. As we've got North Pole oriented coronal holes rotating in here as we get the stream from that South Pole oriented coronal hole. It is weak. Don't expect it to last real long. As you can see, it doesn't have a lot of longitude to it. It's mainly vertical there in the north-south sort of orientation. But these new North Pole coronal holes are a little bit more extreme. So yeah, those should provide a little bit more space weather for your space weather pleasure. Yeah, that'll make geomagnetic storms a little more likely as well. Here is our heliosphere, and Earth has just moved into a North Pole magnetic sector. So moving into the North Pole sector as we get the South Pole coronal hole high-speed stream from this coronal hole right here. So, but it's weak. It's only 540 kilometers per second or so. So yeah, the electron storm, it looks like we're dropping down here to more reasonable levels still. Looks like your GPS performance will be affected. So this is close to alert thresholds. And if you want to know more about the ionosphere, let's take a look at the, let's see, what is it? It's called the Australian Bureau of Meteorology. The Ionosonde from the Australian Bureau of Meteorology. Here, I'm going to show you an ionosphere map. It's going to show you the vibrational frequency of the ionosphere. So there you go. There is our F2 map. Now we're going to reorient this. Oh, no, we'll leave it there. So oriented at 0 degrees longitude, you know, Greenwich, England. So here is our ionosphere map. We're going to load the previous day. And you're going to see very big blobs of high frequency here. And those are going to be the areas that will be associated with GPS errors. Now, this isn't the total electron content, which is a different data set. I'm going to show that next. But this is the vibration of the ionosphere itself. So the particles, the charged particles that make up the ionosphere, this is the frequency at which they're vibrating. And that's at the F0 of F2 layer. So there are multiple layers to the ionosphere. And if you look up here, watch. I don't memorize these type of things, but ionospheric layers. There you go. So there are the different regions. The F layer. Those are the upper layers. Please just show me the image. Come on, Google. There it is. So there are the layers. And of course, the ionosphere puffs up in the daytime. So, at night, you just have the E and F layers. And in the daytime, you have these other layers because, again, as you can see on the diagram, that's a great diagram, it puffs up at nighttime. I'm actually going to save that image because that will be useful for future videos. Let's put it on the desktop, shall we? Just kidding. This is a dictatorship. All right, so we're going to show the total electron content map as well. And that is because I'm going to briefly explain how GPS errors work, okay? When there are a lot of charged particles in between you and your handset, in between the satellite and your handset, you can have huge GPS errors. So let's see. It's down here, I think. No. Where is it at? Looking for total electron content. There it is. So this is the total electron content going all the way up to the outer Van Allen belts. This is literally the electron count the ion, I'll just say the ion count, the electron and ion count in between you and your GPS. So these are the places you'll see GPS errors. Now, most people that live at the equator, they're well aware that, their GPS isn't going to work between, 9 a.m. and 3 p.m. or something like that. Depending on how far from the equator you are, your GPS errors will be less pronounced. But there will be some errors today. And this map is going to give you some idea of where and when they're most likely. I know you probably can't read the timestamps. Most of our viewers are American, so let me just, there we go. That's a great depiction of what we would expect. And of course, you can see the South Atlantic anomaly there, the way it gets real funky over Central South America. That's the South Atlantic anomaly in effect. Yeah. So yeah, the number of ions in between you and your GPS satellite make the signal refract, and sometimes a lot. Your GPS can be off by thousands of miles because of a dense column of charged particles between you and your handset. Keep in mind, the satellite and your handset. Keep in mind those satellites I think they're at about 26,000 miles. So there's a lot of space for stuff in between you and your GPS satellite, and that's the signal gets refracted. This is actually how we measure the ground. Let me see. There is a map about this. I forget which one it is. There is a map that actually shows you the stations. But anyway, we're going to close out this space weather video with some more footage of the closest star. We're going to zoom in on those active spots, and it's going to be freaking cool. Wo ist das? Did I leave the page? How did I lose my tab? My tab has vanished. There it is. The hell? All right. So yeah, that's the past like 2.5, 3 hours there. And again, this area right here, this filament looks like it is mobilizing as we stream. So we're going to let that play for a minute. I'm just going to press mute and let the live stream play. Feel free to leave a comment. Tell your friends and foes about us. Press that share button. Look, daily space weather. Who does it? Who does it coherently? What's that? Nobody? I know, right? So, yeah. Thanks for tuning in, folks. We're going to show this through some different wavelengths here too. So also look at this filament up here. This filament is freaking bonkers. Look at that thing. This is hundreds of thousands, maybe over 1 million kilometers in length. That, if ever a filament on our channel deserved a name, that one right there. Name that filament. Hey, thanks for leaving a comment, All the Sun. You have a fine day as well. And thanks for commenting. Our only comment on this entire stream. Don't worry, folks. The algorithm totally works correctly. It's not a completely broken mess of nonsense. No. Google is totally competent at writing code and making apps. Yeah, so this area right here, look at this. This filament is looking pretty unstable. Wouldn't you tend to agree? Let us know in the comments what you think. Again, I'm going to let this stream. We're going to show a couple of other wavelengths here real quick. We'll show 94 angstroms because it's going to highlight the active zones. There we go. And pardon the guerrilla filming, but when we live stream in portrait in landscape mode, nobody sees the videos. So take that as you may. Blame the algo if you like. Whatever. So yeah. We're going to switch that back to 304 angstroms so the filaments are more visible. And I'm out. But thanks for tuning in, everybody who has. Congratulations on realizing the channel exists. I've been your host, Dan, a.k.a. Smash on Mash, signing off. And until next time, may that solar wind be at your back.